Alright, hello everybody, and today we're going to be integrating our x without integrating x. So, how can we get started with this? I'm going to start by calling this integral I, just so we know what we're solving later on. And well, let's start by looking at this integrand right here. I hope you agree with me that if we multiply our x in this integral right here by a 1, it's not going to change anything, because x times 1 is the exact same thing as x. Just like 3 times 1 is equal to 3, and pi times 1 is equal to pi, okay? So therefore we can agree that x times 1 is equal to x, and that these two integrals here are the exact same thing. So let's take a look at this integral right here. Notice that we have two parts kind of. We have this x and this 1. So maybe it's a good idea to use integration by parts since we have two parts right here. So integration by parts, I'm going to be using the DI method for that. So I'm going to draw my DI table and my plus and minus on the side. And well, now it's just a matter of figuring out what we want to differentiate and what we want to integrate. So we don't know how to integrate this x right here, so maybe it's a wise idea to differentiate it instead. So we're going to be differentiating our x, and while we're left over with this 1 right here, so we're going to be integrating this 1. Why not? Okay, and now it's just carrying out this operation. So differentiating x, we're going to get 1. Integrating 1, we're going to get x. So what exactly is the result of this integral right here? Well, this integral I is the exact same thing as the product of this diagonal right here. So x times x, but x times x is x squared. So we're going to have x squared. And then this row at the very bottom right here is still an integral. So we're going to have minus the integral of 1 times x. But from this line right here, we've established that 1 times anything is that something itself. So 1 times x is the exact same thing as x itself. Okay? So what did we just find out right here? We found out that our original integral I we wanted to evaluate, our I right here, is the exact same thing as x squared minus this other integral right here. But this integral right here looks very familiar because that is the exact same thing as our original I we started off with. So therefore we conclude that our I is exactly the same as x squared minus another I. And this is very nice because notice we can add I on both sides because we want to solve for our I, remember? So if we do that, we're going to get 2I is equal to x squared, and well, we want to isolate this I because I is the thing we're trying to solve for. So if we divide both sides by 2, we're going to get that I is equal to 1/2 x squared, okay? And notice that we're integrating this thing without upper and lower bounds, so make sure to put down a plus c, and we are done pretty much. So our integral of x dx is 1/2 x squared plus c. And notice we did not integrate our x at all using the power rule, reverse power rule thing for integral, whatever it's called. So yeah, that is how you integrate x without integrating x. So hope you guys enjoyed this video, and I'll see you next time. Yeah.